Hey guys, welcome to the online notes for Unit 5, Lesson 2 on graphing exponential functions. So last time in class, we left off with analyzing this parent function. This was the exponential function. We analyzed a few concepts. We talked about when the function increases and when the function decreases. So let's just kind of recap on that, and then let's go over using a table to graph an actual exponential function. So if we look at the red one, we notice that the red one is decreasing with time. So let's take a look at that one first. Um, if I were to rewrite the function, so let's rewrite it down as f of x is equal to 2 or 20,000 times 0.985 to the x power. All right, if we were to rewrite this function and compare it to our parent function, so I'm going to write the parent function right below it. We can compare a few things. We know that our a value is at 20,000, and we can also conclude that b is 0.985. That means that b is less than 1. So we stated in class that anytime, let me just write that down. So b is 0.985. So anytime b is less than 1 but still greater than 0, we know our function is decreasing with time. So to write that formally, let's put b has to be greater than 0 but less than 1, meaning anytime b is a positive decimal, then we're dealing with a decreasing function. Now let's take a look at the increasing function. So this is important. Let's put a little box around that. So for our increasing function, let's rewrite this one. We have that f of x, that would be this one up here, is equal to 600 times a quantity of 1.018 to the x power. So if I were to write my parent function right below it, there's a few comparisons that we can make. This would be a, b to the x power. We notice that our b value is 1.018, which means it's greater than 1. So something we concluded in class was that anytime b is greater than 1, then we're dealing with an increased function, or our function is increasing with time, which makes sense. If we're above 1, we're multiplying by a higher factor. So our function just keeps increasing, 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 and going on and on and on. So these are two things that we can conclude for graphing, and we're going to use on the next example. So let's take some time and run through the next example. Let me just magnify this a little for you guys. Okay. So for this one, we're asked to graph each of the functions. Just to kind of start off, we notice that our function is f of x is equal to 3 to the x power. So if I were to rewrite again my functions, so this would be f of x is equal to 3 to the x power. When compared to our parent function, f of x is equal to a times b to the x power, we can conclude that a is going to be this 1 value because we're multiplying by 1, or a factor of 1. Let me write that down. 1. So then we can say a would be equal to 1. Our b value is equal to 3. At this point, we know that b is greater than 1, so we know that this function is going to be increasing with time. So we can already state that it's increasing. And in our mind, we know that our function is going to be going up with time. So let me go ahead and just prepare my Cartesian plane, and let me draw my x and y axis. And okay, so what we're asked to do is we're asked to use our calculator to complete this table. So at this point, you guys can use your cell phone calculators or the calculators provided for you guys in class. I have the TI 84, the one we use in class, so let me turn that one on. So our function is 3 to the x power for the given values. So let's go ahead and type that in. 3 to the power of, and on top we're going to start with negative 2. When we press that, we just get 0.1111. So let's go ahead and write that in, 0.11, and just kind of round off. What you can also do in your calculator, guys, to save time is if you press second and enter, it actually does like a copy-paste function. So just move the arrow to the exponent and change that to a 1. Now this becomes 0.33. So now it's 0.33. The next one, add 0. If you use your copy-paste function, you switch this out. Oops. To 0, and we get 1. And then 3 to the first power would be 3, 3 to the second would be 9, and then we'd have 27. 3. Let's just check that. Good. Alright, so and then we have our ordered pairs done for us. So this becomes just kind of a basic graph. So when x is negative 2, y is going to be 0.11. When x is negative 1, y is going to be 0.33. When x is 0, y is 1. When x is 1, y is 3. When x is 2, y is 9. And when x is 3, y is 27. So let's go ahead and plot these. 1, 2, 3, 4, 5. And then we'll go up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. So for the first point, let's get a couple of these negative values in here, negative 1 and negative 2. For the first point, we have negative 2.11. That's fairly close to 0, so we're just going to write that point there. The second one is negative 1 and 0.33, so that's below 1, somewhere around there. 0 and 1 is right at our y-intercept. 1 and 3 there. 2 and 9, it actually goes all the way up here. And we can't really graph 3 and 27. You can see how rapidly this function grows. So if I were to just connect my dots, I create my exponential function. Well, that's a bad line, but I mean, you guys get what I'm aiming for. So that's all you really have to do. The bottom portion of this asks us to analyze a few things. So our x-intercept, we know that because we have this function is exponential, and we have an asymptote at our x-axis, which is y equals to 0, then it's never going to intercept our x-axis. So we know that this will be none. Our y-intercept, we found out it was right here at 0, 1. So 0, 1. Our asymptote, y equals 0, that's this line, or our x-axis. It's never ever going to touch, just get very, very close to it. Our domain is all of our x values, and then our range is anything above the y or the x-axis. So range is going to be y is all values greater than 0, domain all real numbers, and this function is increasing. And that's essentially how we do a graph, guys.